Hey team, we are back for week 4 of Trig. We have Unit 3 coming up this week. We're going to spend this week and next week going through Unit 3, and then we're going to spend the next 2 weeks doing Unit 4, and then we are done with Trig. So Unit 3 is probably the trickiest of all of Trig. We're going to talk about verifying Trig identities. And so make sure that you're hitting me up with any questions you have, and anything you need, make sure that you're asking for help. So let's get started on trig identities. So the first thing we're going to talk about are the trig identities that we discussed in Unit 1, which seems like forever ago. So we talked about reciprocal identities. Those are the things that flip upside down. So sine is 1 over cosecant. Cosine is 1 over secant, tangent is 1 over cotangent, and so on. We talked about the quotient identities. Tangent is sine over cosine, cotangent is cosine over sine. And we talked about the Pythagorean identity of sine squared plus cosine squared equals 1. To go along with that, if I take that whole equation and I divide everything by cosine squared, sine squared over cosine squared would be tangent squared, cosine squared over itself would be 1, and 1 over cosine squared is secant squared. So that's where that equation comes from. If I take my original equation and divide everything by sine squared over sine squared is 1, cosine over sine would be my cotangent squared, and 1 over sine squared is cosecant squared. So that's where those other two are coming from. They're just variations of that original Pythagorean identity. The other thing we didn't talk a whole lot about are called even-odd identities. And basically, they're saying if you have a negative in parentheses after your trig function, what happens? What normally happens is that negative just goes out to the front. That's if you have an odd trig function. All your trig functions are odd except for cosine. Cosine is even, which means the negative just goes away. And so since secant goes with cosine, secant does the same thing. The negative just drops out. Everything else, that negative, transfers out to the front. So those are our basic trig identities. We're going to expand on those. We're going to use those through Unit 3. So what does it mean to verify an identity? When we verify an identity, we show that one side of the identity can be simplified so that it's identical to the other side. Another word for this that you really hate to hear is proof. We want to prove that that's equal. So an example of this, I want to verify that secant of x times cotangent of x is the same as cosecant of x. I want to verify that these two things are equal. So how do I go about that? Well, I just take this left side, secant x cotangent x, and I say, okay, what do I know about secant? I know that's 1 over cosine. What do I know about cotangent? I know that's cosine over sine. And now that I'm looking at this, I ask myself, what happens? Well, if I have a cosine x on top and a cosine x on bottom, I know those are going to cancel each other out. So if I cancel those out, all I have left is 1 over the sine of x. And I know my reciprocal identities tell me that that's cosecant of x, which is what I wanted to end up with. So that right there is verifying the identity. I showed that this side of the equation ends up equaling this side of the equation. So some helpful hints for verifying. Start with one side of the equation and stick with it. Typically, you're going to want to start with the complicated side. It's easier to take something complicated and simplify it down than it is to take something simple and complicate it. We want to turn everything into sine and cosine typically. It's easier to turn a tangent into sine and cosine and then kind of cancel stuff out. If you've got fractions and you're adding and subtracting, find a common denominator. And remember your rules from algebra, factoring, foiling, whatever it might take to simplify stuff down. So using those helpful hints, let's try a couple more examples. we're going to verify sine times tangent plus cosine equals secant. So my first step, I want to decide which side I want to play around with. And to me, the left side is more complicated, so that's what I'm going to start with. Sine times tangent plus cosine. So now I've got to decide, what do I do with that? Well, one of the helpful hints said, turn everything into sines and cosines. So sine is going to stay sine, tangent is sine over cosine, plus cosine stays cosine. So now I use my algebra rules. That's like sine over 1. And when I multiply fractions, I just multiply. The top times the top would be sine squared x over 1 times cosine is just a cosine of x. And then that plus cosine still just hanging out. So another helpful hint said, if I'm adding fractions, I need to get a common denominator. So this guy has a denominator of cosine. This guy has a denominator of 1. So I'm going to multiply it times cosine over cosine. If I multiply cosine on the bottom, I have to do it to the top. So this guy's going to stay. Think of that as cosine x over 1. So cosine times cosine is cosine squared over cosine. Now that I have a common denominator, I can combine top plus top, sine squared plus cosine squared, over my common denominator of cosine. And now I look at the top and I see sine squared plus cosine squared. Pythagorean identity tells me that that equals 1. And 1 over cosine x, I know, equals secant of x. And hey, that's what I wanted it to be. Keep in mind your goal. Don't forget what you want it to equal, because sometimes you might get going and forget, hey, that's where I wanted to stop. So once you end up with what you wanted, you have just verified that identity. So let's try one more. This one's kind of tricky. Sine over 1 plus cosine equals 1 minus cosine over sine. Which side's trickier? I don't know. I'm just going to stick with the left. Sine over 1 plus cosine. What do we do with this? It's kind of tough. Everything's already in sines and cosines. So this is where we're going to use a little trick. I know I want to end up with a 1 minus cosine on top. Right now I just have a sine. So I'm going to do what I want, and I'm going to multiply a 1 minus cosine to the top of that. But if I do it to the top, I have to do it to the bottom. So I'm going to multiply this together. Okay, on the top, I'm just going to leave them separate because I know that's what I want to end up with. So I'm not going to multiply that in. But on the bottom, 1 plus cosine times 1 minus cosine, we have to FOIL that. So 1 times 1 is 1. My inners and outers are going to cancel. I'm going to get a negative cosine and a positive cosine. They cancel out. And then last, cosine x times negative cosine x is negative cosine squared x. All right, what do we do with that? Well, 1 minus cosine squared x is that Pythagorean identity rearrange. I know sine squared plus cosine squared equals 1. If I subtract cosine squared from both sides of that, I get sine squared x. Well, now I have a sine on top and sine squared on the bottom. So one of those cancels one of those. So that sine on top cancels 1 sine of x on the bottom. So now I have 1 minus cosine x on top and a single sine x on the bottom. And hey, that's what I wanted to end up with. Done. That one's pretty tricky. That trick at the beginning is pretty crazy. So that's about as tough as those are going to get. They get kind of tough. If you have questions, make sure you're asking me. Hit me up, email me, whatever you need. If we need to do a Zoom sesh, I'm cool with that. We are going to do one more thing. This was section 3.1. We're going to talk section 3.2. 3.2 is sum and difference formulas. These are all the sum and difference formulas. So I'm going to attach the notes for this section. So if you want to take a minute and jot them down, you can pause it and write these down, or you can look at the notes that I attach. but we're going to use all these formulas. What these are saying is if I take the cosine of one angle plus another angle, I can use this formula to find it. Same with all of these. You can't say something like sine of 30 plus 60 is the same as sine of 30 degrees plus sine of 60 degrees. That's not how it works. You have to use these formulas. So that's what they are there for. Why? Why do we use this? How do we use this? Well, let's say I want to know the exact value of cosine of 15 degrees. When I say exact value, that means no decimals. Okay, you could put cosine of 15 degrees in your calculator, you're right, but that's going to give you a decimal. It's not going to give you the exact value. These are probably going to have square roots in them. So your answer is probably going to be like a square root of something plus or minus a square root of something. So what we're going to do is we're going to use our unit circle angles. We know the sines and cosines of all the unit circle angles. So when it says find the exact value of cosine of 15 degrees, I say, okay, what unit circle angles do I know that I can make 15? How can I add or subtract stuff to get 15 degrees? Well, I know 15 degrees is 60 minus 45. You could do 45 minus 30. You could do all sorts of things like that. That's just what I chose for this one. So now I know that cosine of 15 is going to be cosine of 60 minus 45. So if you look at those formulas, my alpha is 60, my beta is 45, and I'm going to plug into that big old formula. So it's cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. So I plug in 60 wherever there's an alpha, 45 wherever there's a beta. So I've got cosine 60, cosine 45, plus sine 60, sine 45. And this is where your unit circle comes in. The cosine of 60 degrees, look on there, and I know that's 1/2. The cosine of 45 is square root of 2 over 2. Plus sine of 60, I know is square root of 3 over 2, times sine of 45, I know is square root of 2 over 2. And from here, it's just simplifying. When we multiply fractions, top times top, bottom times bottom. So 1 times square root of 2 is square root of 2. 2 times 2 is 4. So square root of 2 over 4. Square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. Oh, look, we've got a common denominator, so we can combine and say that's the square root of 2 plus the square root of 6 all over 4, and that's as simplified as that gets. So that's your answer. That's all you have to do for that. We're going to try one more. Find the exact value of sine of 7 pi over 12. Again, not on your unit circle. But the way I think of these is I say, okay, how could I get 7? I know 7 pi over 12 would be 3 pi over 12 plus 4 pi over 12. Well, 3 pi over 12 simplifies to be pi over 4. That's on my unit circle. 4 pi over 12 simplifies to be pi over 3. That's on my unit circle. So I can rewrite sine of 7 pi over 12 to be sine of pi over 4 plus pi over 3. So same as the last one, we're just going to use that formula. The sine of alpha plus beta formula is sine alpha cosine beta plus cosine alpha sine beta. So my alpha is pi over 4, my beta is pi over 3. I plug those in. And then I use my unit circle, sine of pi over 4. That's square root of 2 over 2. Cosine of pi over 3, that's 1/2. Plus cosine of pi over 4, that's square root of 2 over 2. Sine of pi over 3, that's square root of 3 over 2. This is pretty similar to what we just did. You end up with square root of 2 over 4 plus square root of 6 over 4. And there's your final answer, square root of 2 plus square root of 6 over 4. So that's kind of how those work. One last example. This is a big one. If the sine of alpha is 12/13 for a quadrant 1 angle, and the sine of beta is 3/5 for a quadrant 2 angle, I want to find the exact value for 4 things: cosine of alpha, cosine of beta, cosine of alpha plus beta, and sine of alpha plus beta. So first, we're just looking at cosine of alpha. I know the sine of alpha is 12/13. We're going to use our x, y, r's for this. So if sine is 12/13, I know y is 12, r is 13. So in order to find cosine, I need x. So x squared plus y squared equals r squared. So 13 squared, that's 169, minus 12 squared, that's 144, gives me x squared is 25. Square root both sides, and x is plus or minus 5. I know it's in quadrant 1. In quadrant 1, x is positive, so x is positive 5. That means the cosine of alpha is x over r, which is positive 5 over 13. Letter A, done. Letter B wants cosine of beta, so we're going to pretend like we never did that problem. We're going to go to beta. Sine of beta is 3/5. We're going to do the same idea. Y is 3, r is 5. So x squared plus 3 squared equals 5 squared. 25 minus 9 is 16. So x is either plus or minus 4. In quadrant 2, x is negative. So my x is negative 4. So then the cosine of beta is x over r, which is negative 4 over 5. That brings us to letter C, cosine of alpha plus beta. We have to use the formula for this. So I'm going to use my cosine alpha plus beta formula. Cosine alpha, cosine beta, minus sine alpha, sine beta. So I have everything I need because of letters A and B. I know the cosine of alpha is 5/13. The cosine of beta is negative 4/5. And then sine of alpha and sine of beta are up here in my problem. So I plug those in. 5/13 times negative 4/5 minus 12/13 times 3/5. Top times top, bottom times bottom. My 5's cancel there. I get negative 4/13 minus this one. You just got to multiply 12 times 3, 13 times 5. Get a common denominator, put it in your calculator, whatever works. You end up with negative 56 over 65. That's your cosine of alpha plus beta. Sine of alpha plus beta, same idea. We're going to use our formula. We're going to plug in all 4 of our sines and cosines. They're just kind of in a different order, and we're going to add. So sine of alpha, 12/13, times cosine beta, negative 4/5, plus cosine alpha is 5/13, sine of beta, 3/5. Multiply, you get negative 48/65 plus 15/65. You have a common denominator, and you end up with negative 33 over 65. So that's how those work. That is it for this week. You are ready for Unit 4 homework. That's all you have to do this week is Unit 4 homework. Next week, we're going to do a really short quiz over this stuff, probably just a handful of problems to make sure you're doing okay with them. And we're going to do some more identities. We'll finish out Unit 3. After this week, we only have 2 more weeks of notes. Our very last week's just going to be the test. So 2 more weeks of notes, and you're done with Trig. Keep working hard. Let me know if I can do anything to help you. You guys are killing it. Keep doing your best. You've got this.